Hi, I'm Printed for Fun, and in this video I will be doing something different. My target or my goal is to create lens protectors or like small standoffs for the MetroY Pro, so it can be placed on a flat surface more easily. So regularly it has these like rubber protectors, so the lenses are protected and the scanner doesn't like hard crash into the table. But I want to have a larger area where I place it under the table, so it is a bit more stable in this upright position, and the result will be printed from TPU. I initially tried to record my reverse engineering process, but I got a bit fed up, to be honest. So I had to concentrate on like narrating my whole process, and this made it quite difficult to really concentrate on the engineering part, and I made some like mistakes or did some useless work. So I decided to like start over. I actually wasn't happy with the result, what came out, to start over, do reverse engineering, and then do like a recording and a narrated story of how I came to my result. As you can see, I start with the 3D scan of the MetroY Pro. It is already aligned to the coordinate system, and what is also quite important, if you look at the coordinate system, I actually set two symmetry planes. So the left and right side of the scanner are symmetric, and the top and bottom are symmetric, and this simply makes it easier for the construction, since you can see here the top and the bottom are symmetric, so I only need to construct one of them and then can mirror it. So first step was making a sketch actually. This sketch will define like the rough shape I want to have for the MetroY, or for the lens part or the placeholder. It was important for me that I follow like this natural curve on the inside and outside, and include the original rubber standoff. So it isn't just based around, I want it to be included. The final result will be like glued to the scanner with some reversible double-sided tape. This is commonly used in phone repair. It's roughly 0.1 to 0.2 millimeters thick. What's also quite important for the result to look nicely is that the center points of these arcs are placed on the symmetry line. So when mirroring the result, I get like a nice smooth curvature. I don't have like additional edges added in. The next step is extruding the lens protector. You can see I extruded it to roughly, if I go to the analysis tab, I extruded it, we will say to 0.5 millimeters now, to be roughly 0.5 millimeters over the original standoff, so it is included and I don't have a cutout. And on the side, I also extruded it past the original scanner. As you can see here, this will simply allow me to cut this part with the original scanner surface. So I get a nice cutout. So we'll reverse the transparency now. Next part is like modeling, or more like filleting. So as you can see, I'm just adding multiple fillets here. In the new Quicksurface 2026 version, it also added adaptive fillets, I would call them, where you can have multiple radii. As you can see here, so the outside radius is at 1.3 millimeter and the inside is at 2.4 millimeter. This simply makes the result a bit more optically appealing, I would say. This is new in the 26 version. I just recently, before recording this video, I tried to open the model in the 2025 version of Quicksurface, and it actually would not open correctly. So it opened, but I had some errors since it doesn't support this type of fillet. And also I am happy to announce that, at least for me, Quicksurface hasn't crashed since then, or since the update to 26. So I formerly was on 25, and sometimes with very large trims or like complex filleting workflows, Quicksurface something crashed. I actually spoke to the guys at Quicksurface on FormNext, and they're supposedly using a whole new CAD kernel, I would say. So from my IT background, it sounds like they changed the CAD kernel, like changing the Linux kernel. Okay, so next step is quite interesting, I would say. So now let's hide the first solid. My next goal is creating like the shape, or recreating the shape of the scanner to cut from a solid. For this, I isolated the scanner shape, or the relevant parts for me. And in the first step, I created a fit surface over this part. Fitting a surface is actually quite easy. You just like select the area, or interactively select the area, and then say, fit me a surface over this selected part within, I said, 0.1 millimeters of tolerance. It tries its best, and as you can see, for the relevant parts here on the top, it reached this tolerance. Next step is fitting a plane here on the top. And I also created a sketch through the mesh. This sketch will reconstruct the original rubber, since I don't want to pry it off. I guess it could be pried off, then it would have made the construction easier, but it actually wasn't necessary from my opinion, and it still worked without prying it off and like damaging the scanner. So these are basically two arcs I fit around the points, and on the side I added two lines, like a line here, and then dynamically created the ready. This now then gets extruded, also by using the snapping mode. Snapping is quite nice. You can like simply enable snapping, and then it will like stick to the scan data. But I don't want to change this now. Then I will fillet this extruded part to closer fit to the original rubber part. And in the next step, that's quite nice, or I would say one of the key features of Quicksurface, I trim. And with trimming, I recreated the scanner shape that I want to cut from my other part, to cut from this part. And if you now look at the comparison, I'm toleranced within 0.1 millimeters, and generally I'm saying for 3D printing, I'm fine with 0.1 millimeters. Keep in mind, what's relevant are red spots for me, or yellow spots, so as you can see here. The blue spots, there is the CAD part or the surface actually above the mesh. So this will be more like a cutout in my final printed part, and not a protrusion I don't want, or that interferes with the print, and it will be printed from TPU. So there is a bit give to the part. Then in the next step, I trim again to come up with the lens protector shape. I'm just currently noticing I could have also used a draft extrusion for the protector itself to like capture this nice arc of the scanner a bit more. But it worked without, and now I don't want to reprint the whole part and reglue them to my scanner. Maybe it will be done in the future. So then what will I do next? Since I'm gluing the 3D print to the scanner with double-sided tape, the tape has some thickness. It's roughly, from my experience, 0.1 millimeters of gap are quite nice, since the tape is a bit more, so I get a bit of friction. So I move the faces, also like the relevant faces, by 0.1 millimeters. And that's also quite nice of the new Quicksurface version. With the 25 version, this wasn't possible in Quicksurface. So I always had to like export it to Fusion. But yeah, so that's quite nice for me. I'm just remembering I also added tape to this part, so it glues to the original rubber. So I will actually let's see. I will actually move this up by 0.1 millimeter, the surface. This can be done quite easily. So I simply, currently you're seeing I have def 1 and def 2. Def 1 is at 0.96 millimeters. I could manually add 0.1 millimeters to this value, or I could just say set sketch on top plane, and the new value for top plane is 0.1 millimeters. So, and it actually broke the trimming a bit. Let's see where it broke. Ah, I see. It broke here, since it has like new interference. So this should fix the problem. And when we're at this point, I can also try to maybe add a bit of draft. It could look quite nice. But now I actually won't add draft, since as you can see, I'm moving out of the part now, and this will make the trimming a bit more difficult. So going back to the design process, sorry I got caught up in improving the design further, but actually at the moment I'm quite happy. So let's first let's show the mesh again. In the next step, I added 2 fillets. As you can see, these are simply, these make the part better printable, since printing these very, very thin walls from TPU works to some extent. So I'm using a Bambulab A1 mini printer. It's like the ideal TPU printer. For anyone searching up TPU printer, get the A1 mini, since the aim is light, also works with TPU. So I have like 4 different TPU colors loaded in the aim is light. I needed to create some fit shims. So like you have kind of extruders in the aim is light itself, and you have to add a small shim to it, so there is less tension on this extruder, and then it also works with TPU. But this was an excursion and not relevant for this part. I'm very sorry. But yeah, I guess I would say too, there is a lot of experience for different topics, and different experience is simply needed for a lot of the successful designs in the end. So, first part is finished. Now let's mirror it. What I also did, you see in this first part, but after mirroring, it is still registered as one body. With the 26 version, you can also split this body into multiple bodies, so they could become independent. And in the last part, I simply moved the bottom scan a bit. So you can see here, there's a slight gap. I just moved it a bit. It wouldn't have been necessary. It's just for correctness, I would say, to be happy. And at this point, you can just export the step files and 3D print them from TPU. So if we go into the Orca slicer now, I'm going to my lens protector. We have it here. Now they are exported as one step file, keep it in mind, so I can split them. With Control A, I select both. I can auto-orient them. I press A again to align them. Control A to select all. Control K to create a copy. A again to align. And Control A again to select all. And now I press 4. So filament 4 is selected which is my TPU, and Control R for the rendering slash slicing. I remembered this shortcut by having it in my head as a rendering step. So yeah, as you can see on the A1 Mini, it takes a total of 21 minutes print time. Not, I mean 28 picture, but I don't do the flow calibration for TPU. I preferred setting a manual flow rate, a manual how's it called, pressure advance ratio. So yeah, you can then print them and add glue sticks or glue stripes to them. I actually have the pictures on my smartphone. In the corresponding post, I will also include the final pictures. So I'm back. I just transferred the pictures, and as you can see, I added the 3D printed parts with double-sided tape to the scanner. This is like the starting point where I had no protectors, and the scanner is like only resting on the center rubber parts. And as you can see now with the new parts, they're just resting on a wider area. So yeah, I'm quite happy with the design. And what I would say, that's the last point and why I recorded this as a separate step. The whole reverse engineering process I walked you through now took me, without narrating it to you, a total of 20 to 25 minutes. So when you're accustomed to the software, you can become quite fast, I would say. And it is actually, so sometimes I'm hearing like, oh, why did you use reverse engineering? Why did you 3D scan it all? You could have just used calipers or measuring tape. And yeah, that's true for some parts. But once you dialed in your workflow and feel confident with the software and now know what steps to do and how to approach a design, which is like experience simply, you get very, very fast, and it fit on the first iteration. So I just designed it in 25 minutes, printed it in 20 minutes, and glued it on the scanner. And I hadn't to redesign, reprint the whole part, and maybe design a third time. So yeah, that's my response why I'm using reverse engineering.